take a look at the question and then try to solve it yourself. If you can solve it, that's best. Yeah. Okay, if you can solve it, check the answer at the end of the video. If you cannot solve it, continue watching the video and I'll explain why. Okay, so AOB is the diameter, so this length is the diameter, so it means we know that this is the longest length of the circle, and we center O. Okay, C is the point of the circumference, K lies on AB. Okay, so K is just a random point on AB. C is the point of circumference. CK is perpendicular to AB. To be honest, right, no matter where C is, it will still be perpendicular to AB because it will be a horizontal line down. It will be a vertical line down. Yeah, so it's perpendicular. Okay. K lies on AB such that CK is perpendicular to AB. K lies. Okay, show that ACK is similar to CBK. Okay, how do you show it? It's very simple. ACK. If you cannot solve it, right, take a look at the next few questions. Sometimes the next few questions will give you hints on, like, will give you ideas, okay, to solve it. But anyways, so ACK is similar to CBK, so we know that this is similar to this. We know that no matter what, we can, one way of to show it is similar is by SS, by the side method. Actually, just need to show that the sides are just in correct ratio, corresponding sides ratio of the corresponding sides are equal, right? To show that it's similar. Okay, but in this case, can't show the sides because you cannot find. They didn't give you. Ignore question 2, part 2, question 2. They didn't give you length, so definitely cannot use length. So what you have to do is use the angle. Find the angle of this, find the angle of this, find the angle of this. Okay, so we know the angle of this is 90 degrees. And I knew angle ACK equals 90 degrees. Reasoning, what? Adjacent angles on a straight line. That's all. This is 90 degrees. Got it very smaller a bit. So this is 90 degrees. Okay, so we know one angle already. So angle ACK is equal to angle CKB. Not ACK. AKC. Angle AKC is equal to AKC. So this is my S. No, this is not my S. My A. To test for similarity, I need to get another A. There's one more A. So it can be this, or this. Anything. Okay. So I need to get another angle. Okay. So now, what I want you to do is how do you prove that this angle is equal to you prove that this angle is equal to this angle? This angle is equal to this angle. It is possible, but it's the same method to find both angles. But we just need to find one angle that's similar or equal. So extend CK. You can draw it on the paper and your examiner will mark it by the paper. Okay, CK. Okay, let's draw CK. Let's extend it. Okay, such that this is also equals also like that. Why? So and then label this as D. Okay, you know angle DKB is equal to 90 degrees. Such that so you need the label and state it clear first. CKD is straight line. It's a straight line, yeah. So you label it first. That was in the marker. Okay, DKB, this is D. DKB is equal to 90 degrees. We reason adjacent angles on a straight line. Okay, this 90 degrees. So what can we see here is that this is the chord CKD. This whole thing is a chord. Can you see that? This thing is a chord. And what else? If this is the chord and this is the perpendicular bisector. Okay, we know that CK. So now I need to tell you okay, CK is equals to KD. Why? Because it's perpendicular bisector of chord what? Chord AB. You don't have to write AB, but you write AB so that you are clear. Okay. So what does it mean? It means CKD is perpendicular. Okay, AB is not chord. AB is a chord, but it's not chord AB. It is supposed to be chord CD. Okay. Okay. So CD, this chord, it cuts it down here. So basically, this is equals to this length. Okay, first of all, you know that this is 90 degrees. You know that this is 90 degrees. That's the first thing you need to know. Second thing you need to know is that it cuts this bisector, cuts O into 2, cuts at the center, cuts it into 2 at the center. If AB is like that, definitely not bisector, because this is more lesser, this is more. Why? Because it's not in the center. But now it cuts it directly into 2. Yeah. So 3 different properties to check. Okay. This is a bisector because the bisector itself cuts O in the center. Okay. Cuts O in the center. It also cuts it at 90 degrees. So it doesn't just have to cut it center, it cuts at 90 degrees. So hence both sides are equal. Okay. Yeah, so it cuts it. So CK and KD, vertical bisector of chord. So so essentially now I draw a triangle. You don't have to write the explanation for this. Anyone knows? Just write it down. Triangle CKBK is equal to triangle DBK. Reason for, so basically every angle here is the same. Reason for it, because this side is the same and this is the same. And this is definitely the same, going to be the same because of Pythagoras theorem. Yeah. So that's all. So now we know that this is the same. Okay. And over here we can see, clearly see one property, and if you see in a circle, confirm there's a property of like geometric property of circle. This angle is equals to this angle. This angle is equals to this angle. And so okay, so I'll tell you something. Okay. Just write out the angle first. Okay, so angle CAB is equals to angle CDB. CAB is equal to CAB equals to BDC. Let's write it BDC. Why? Yes. What's the reasoning for it? This is the segment. This is the major segment. This is the minor segment. What is it? It is major. Is angles in major. No, angles in same segment. Okay, so we got this. Okay, great. Okay, so now we know that angle CDB is equals to angle CDB is equals angle DCB. Why? Because the base angle of isosceles triangle. You see how this angle and this angle are the same thing. My handwriting is so ugly, bro. I'm not gonna lie to you. Okay, that's all. So you know that this angle is also equal to this angle. So we proved it such that this is what alpha. So conclusion by SS similarity test, this triangle, this holds true. Do you understand that? Okay, I'm gonna erase this so I have space to do the second question. But the second question is easier. Okay, so this question is red color over here. This question is red color, which is advanced. That's why it's categorized under advanced for me here. It is because of the part 1 question, not part 2. Not part 2. Part 2 is easy. Part 2, if you do enough practice for the previous congruence and similarity chapter, confirm can do it. Okay, it's given that okay, we know all of these are similar, so we just label it this equals this, and this is equals to this, and this is just 90 degrees. Okay. That's all. Okay. So given that AK is 12 cm, so this is 12 cm. CK is 10 cm. Is 10 cm. Find the radius of the circle. Okay, so by doing this, we know that 10 cm, right? So we know that they're similar. Okay, they ask you to show. The reason I ask you to show because Cambridge on the paper does not want you to cannot show already, right? You don't know if it's similar, then you cannot do the second question. You lose both marks. So because you know it's a difficult question, they ask you to show. So you can use information. If you cannot manage to show, you can use this information over here to show for this. Can. Okay, find the radius of the circle. Radius of the circle. Okay, so find AC by Pythagoras theorem. AC will be equals to plus minus 12 squared plus 10 squared will be equals to 144 plus 244. 244 plus minus, which is also helping me 244. So I square. I use my phone calculator. Square root 244. Okay, so it's plus minus 15 point. Just plus now. Don't do the minus. That's 15.620499. Blah 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 blah. Don't round off. Just cut, truncate. So what is this equals to? So reject negative. Because AB is AC is more than 0. Okay. Find the radius of the circle. Okay, so now you find AC. Now you know AC is 15.620499. Okay, so now what are you gonna do? You know there's this property where ratio of the triangles are same. Ratio of the corresponding sides in a similar triangle are same. Okay. Okay, ratio. Okay, so what you're gonna do is that AC over from here, AC and CB are corresponding sides. C and CB. So in order to find, okay, actually now my whole main goal is that what I'm trying to do, I'm trying to find this length. So I know this length already. How do I find this length? Because once I know this whole length, I divide by 2, I know the radius. Because this whole thing is a diameter, right? So I know this length. I don't know this length. I have to find it. Okay. So you know that KB is what? KB here is KC. So KB and KC. Okay. So KB and over KC, KB over KC will be equals to any angle that we know. You know CK, right? KB. So you know be CK over AK. CK AK. How do you know? Okay, CK AK. Okay. So now it's a sub in the value. What is KB? KB you don't know. Just leave it as KB. KC. KC is 10. Equals to CK. CK is 10. 10, right? Yeah, 10. Over AK. What is AK? AK is 12. 12. So if you know, doing this, KB will be equals to both sides times 10, so it's going to be 100 over 12. 100 over 12, let's find the exact value. 8 and 0.33, right? Just put it at 8 and 1/3 cm. So KB is 8 and 1/3 cm. So plus together, so KB plus AK will be equals to 20 and 1/3. So total radius will be equals to 10 and 1/6 cm. That's the answer. Radius 10 and 1/6 cm. Yeah.